So hello students, welcome to my channel. So in this video we are providing you about your NCERT class 11th chapter physics, which is the chapter number 2nd, and which name is motion in a straight line. Okay. Previously I had already uploaded one video related to the motion in a straight line, in which I had described about the basic headings which are here I am showing, just like the kinematics that you had been described in the previous video, as well as you are well familiar with the other heading, which is the frame of reference. Okay, what was the frame of reference, why it is used for a motion, and how it is used. Okay, and I had already explained it in the previous video. You can see also I had defined the displacement, okay, as well as distance, what is displacement and what is distance. Okay, and more related topics I also had described in the previous video. Now I will continue my previous video, and in this video I am going to discuss about the upcoming headings of the chapter. Okay, so let's start our video. Our next heading of our chapter is speed and velocity. Okay, we have to define speed and velocity and why it is used and how it is used in our motion in a straight line. Okay, it is a term which we should know. We should be familiar with the speed and velocity. So just in the previous heading you had understand about distance. Okay, about distance and displacement. You had to understand about the distance and displacement. And what was I had said, that distance is the actual path, and displacement is the shortest path. So I had explained this in the previous video. You can see. Okay. Also I had told that distance is a scalar quantity. Scalar quantities means those quantities which have only magnitude. Okay, and I had told about the shortest path, displacement, that is it is a vector quantity. So on the basis of quantity I had explained, as well as on the basis of path it occupy. Okay, now if we will relate speed and velocity, they are in the same sense. We know they as the same sense in that of the distance and the displacement. Speed is related to the distance and the velocity is related to the displacement. And how it is related, I am going to discuss about it. So if I define speed, so it is said that, okay, what is the definition of speed? So speed is the okay, distance traveled. We can say speed is the distance traveled by a body. Okay, by a body, we can say speed is the distance traveled by a body or unit time, means per second, or for any unit we are using, per millisecond, per microsecond, or per second. What is the value of speed, means how distances is traveled, how is the path are covered, that is defined as the speed. And if we will write it in the form of formula, then we can say speed is equal to distance per unit time or upon minute time, means it is the ratio of distance and time. Okay, we can define it is in this manner, and it is related directly to the distance. We are seeing also here that speed is directly proportional to the distance. So here we can understand what does it mean, that if we will increase speed, then our distance will also increase, and if we will decrease our speed, then our distance will also decrease. That is the relation which is the directly relation. Okay, now indirectly relation is inversely dependent. So you can understand it here. Also if we will talk here what about the speed, that is the speed is a scalar quantity, because we know that the speed depend on distance, and also we know about time is a scalar quantity. Previously we had already discussed in first chapter, which is the units and measurement. And here, because speed is depending on distance and time, then if we have to define the direction or magnitude of speed, then we have to see about the distance and time. So we are seeing that distance is a scalar quantity, time is also scalar, and scalar upon scalar is a scalar quantity. That's why our speed is a scalar quantity. So in this manner we can define it. And if we will talk about its unit, if we will talk, because you already know about how to find unit and dimensions as well as measurements of a physical quantity. So unit of a speed, if we talk unit of a speed in Celsius, then it is because we are seeing the formula speed is equal to distance upon time, so it is centimeter per second. Okay, and we can write in various manner here. Centimeter second inverse we can also write, and as well as we can write centimeter per second. Okay, so this is the Celsius unit of speed, and if we talk about the SI unit of speed, that it will be the meter per second. Very easy concept here it is, and if you will try to understand it in very clear way, then you can understand. So here it is clear that what is the unit of speed, as well as one more thing which is asked in the examination is about the its dimension. Okay, na? So dimension is also, you know how to find dimension. In previous chapter I had already told. Okay, so dimension is because we have the formula as well as we have unit, so we can easily determine its dimension. Dimension is always written in square bracket, and the dimension of this quantity is LT minus 1. But always remember that you have to mention about the MLT, 3 basic quantity. 3 base quantity mass also have to be written, and it is the M0L1 Tp minus 1. It is the dimension of speed. Okay, so it is clear what is speed. Means suppose here is a body. Suppose here is a body. A body is at point P and it is traveling. Okay, in time t. It is taking time t to go at second point P dash. Okay, and if it is traveling x distance, if its path, actual path is x distance, so in this manner we can easily define about its speed. That is what its speed. We can denote it by v. Okay, now we can denote it by v, and speed is equal to distance upon time. With the help of this formula, we can say x upon t. So v is equal to x upon t is our value of speed. So in this manner you can easily know about the method and concept of the speed. Okay, so now it is clear what is speed. Now I'm moving to the next point, which is the velocity. Okay, both are very related to each other, just like distance is related to displacement. Here speed is also related to the velocity. Okay, so let's discuss about the velocity. Now our next topic is here our next point, which is in this heading, is the velocity. Okay, we are defining about its speed and velocity. I already had talked about speed, and now we have to talk about velocity. So if we will define it, in first of all we have to know about its definition. Okay, in Hindi we say it as wave. Okay, we say it as wave, and if we will define it as a charge. Okay, here charge. So now if we will define, just like we had defined the speed, if we will define velocity, then what is velocity? So we can say that velocity, it is the okay, change in position. It is the rate of change in position. ठीक है ना? And also we know that what is change in position. Change in position is said to be displacement. Okay, change in position is said to be displacement. So we can say it is the rate of change in position or displacement. Okay, and rate we can say only it is only the definition. It is the rate of change in position or displacement. And because we are saying rate, that it means that rate means that we have to divide our quantity by time. Okay, just that is if we talk it in the form of formula, then we can say that what is velocity in the form of formula. Then we say that the velocity is equal to displacement per unit time. Here we can clearly define it, displacement per unit time, or we can also write here in the place of displacement that change in position, because we know that displacement is only what? It depends only on the initial and final position. That's why we are saying that it is the change in position. Okay, so it is clear what is velocity. Velocity is the rate of change in position or rate of displacement. Okay, now if we defined it in the form of formula, then we have written it. What is velocity is equal to displacement upon time. And similarly, just like we had defined about the speed, we can also define here about the quantity of speed and about the velocity. So here we are seeing that velocity is directly proportional to the displacement. We are seeing this here, that velocity is directly proportional to the displacement. That means it only depends on the displacement, okay, on the basis of its quantity. Suppose we have to find about the dimension as well as quantity, which quantity it is. So we have to say here that velocity is depending upon displacement, because displacement is a vector quantity. Displacement is a vector quantity. That's why our velocity will be also a vector quantity, because we are seeing that time is previously we had said that time is a scalar quantity. That's why our velocity is only depending on the basis of direction on displacement. So we can say our velocity is a vector quantity. Okay, we are writing it here. Velocity is a vector quantity. Now it is clear to us that velocity is a vector quantity. So our next question is that if velocity is a vector quantity, okay, if velocity is a vector quantity, then on which quantity the direction of velocity depends. So from this formula we can say, that the direction of velocity is same as the direction of the displacement. Means if a body is displacing from one position to another, then the direction of the velocity with which the body is moving will be only depend on the displacement, not on the time, because time is a scalar quantity and dimension displacement is a vector quantity. So we can easily say velocity has the direction equal to the displacement. So it is the direction of our velocity, as well as we are clear with the concept that on which direction, on which thing our displacement or direction of velocity depend. Now as we had already told about speed, and in this we have defined two things more, which is the unit and dimension. So now in this also in the term of velocity we will define its a unit as well as dimension. So here if we will talk about the unit, so we can easily here tell that what is the unit of our velocity. Same, just we are saying that because unit and dimension not depend on the directions. Okay, we are already seen in the chapter number first that units and dimension are independent of direction. They only gives us about the quantities used in our physical quantity to define our physical quantity. So because speed and velocities have only one difference, that they are different in direction. Speed is a scalar and velocity is a vector. So here easily we can define the units and dimensions same for both these quantities. Means speed have also the same quantities, means same units and dimension, as well as velocity have also the same unit and dimension. Just here we have defined CGS in SI, centimeter per second, and meter per second, and dimension m0 L1 T minus 1. So we can write here that in a CGS unit our velocity has the dimension which is the centimeter per second, and its SI can be said to be meter per second. And if you talk about its dimension, then it will be m0 L1 T minus 1. So it is what it is our units as well as our dimension of velocity. And now you have to know about what it signify, what velocity says to us in a very day-to-day practice. So suppose here a body is moving, okay, a body is moving from P. Suppose a body is moving from P to another position P dash, okay, in time we are saying that in time T, here time is T, and we are also saying that it is moving in the which direction? It is moving in the east direction, okay. So we are already know that what is displacement. Displacement is a vector, means it will give you a direction. That's why velocity is also same quantity and it will also give you a direction. So if a body is at T position initially and after some time T, it will travel and go to another position P dash. So we have to calculate its velocity with the help of this formula, displacement upon time, and here it is given clearly that displacement is p to p dash. P to p dash means pp dash is the equal to displacement. We can easily say pp dash is equal to displacement. Okay, because pp dash is a vector quantity, so we should have to denote it as a vector and the time approximately. Okay, so here we can clearly define it, and displacement upon time is what? Our velocity. And velocity, because it is a vector quantity, always denoted with a arrowhead sign. A symbol we use it for denoting it as a vector, as well as the arrowhead we use. And what does it signify? It says to us that the arrows is the direction of that vector, and the length of this arrow is denoted by the line drawn above to the our symbol. Okay, and in books you will see a vector quantity in very dark notations. Just we denote vectors in our books as dark letters. Okay, in books you will see like that, dark notations, and in practice we write by our pen or markers, then we will denote it by arrowhead. Okay, vector quantity. So now it is clear for you that what is speed and what is velocity. So let's discuss about our next heading. So now our next heading is that we have to know about some terms which are related to our speed, as well as we will also define some terms related to velocity. First, our heading is related to speed. Okay, so what are the some terms that are related to our speed? So you should know that various terms are related. Just we say as a uniform speed, we have to know about uniform speed, as well as we have to know about non-uniform speed. Okay, non-uniform speed, only four terms are here, as well as there are many terms we have to know, and that will be discussed in our question that we will solve. Okay, and also non-uniform speed is there, as well as we have to know about average speed, and then we have to know about instantaneous speed, and these are very basic concepts. Instantaneous speed. So here are four terms which are related to speed, and we have to know about that. So let us discuss about it. Okay, first of all we have to define here about uniform speed, that what is uniform speed. Then you had already studied it in your previous classes, that what is uniform speed. And if we will define here, then what we can say that if a body travel, we can write it here, if a body travel, here a body is traveling. Okay, and what the body is traveling? Equal distances. Okay, equal distances. If a body travels equal distances in equal interval of time, then our body will be said to be in the state of uniform speed. Okay, then that speed is known as uniform speed if a body travel equal distances in equal interval of time. If we will give example, then we can see here that suppose here a car is moving. Okay, a car is moving, and first of all at the time 2 o'clock, we can say at time 2 o'clock the car is moving with a speed of 5 meters per second, and again after some equal interval, suppose we are saying 3 o'clock, then we are seeing that our speed of this car is 5 meters per second again, and again at 4 o'clock we are saying what? Here again our the speed is same, means at a different time, or we can say at the equal time interval, the speed of body is same, or we can say the body is always traveling the same distances, means after every 1 hour the body is traveling 5 meters, then the body is said to be at a uniform speed, because it has a uniform speed, means it has equal speed. Okay, that body is said to be in the state of uniform speed. So it is clear here with the help of this example, as well as there are various examples that you will be familiar with the help of the question that we will solve. Okay, so here it is clear what is uniform speed. Now the same concept is used for defining our non-uniform speed. Okay, because uniform speed is the antonyms of non-uniform speed, or we can say non-uniform speed is the antonym of uniform speed. And what does it say? It says that if a body travel, but here only one thing is important, that body travel on equal distances. Okay, if a body travel on equal distances in equal interval of time, it is very important, in equal interval of time. Body is traveling, but it traveling on equal distances in equal interval of time, then that body is said to be in the state of non-uniform speed in equal interval of time. Also we say that this speed is also known as variable speed. Okay, so you should also know about it, that the non-uniform speed is also termed as a variable speed. And if we will see it as with the help of examples, so same examples we can take here, the same example, but what the difference from previous examples, we will see that at 2 o'clock the body will be traveling at a 5-meter distance. The body will be traveling, means at 2 o'clock, after we see at the 3 o'clock the body is traveling 5-meter distance. But after the next time overlap, then we are seeing the body is traveling 6-meter distance, and then we are saying that body is traveling 7-meter distance. Means the body is traveling on equal distances in equal interval of time. Here we are seeing the time interval is equal 1 hour, but at every 1 hour the body is changing its distances. That means the body is changing its speed, and that's why, because our body is changing its speed is known as non-uniform speed, or we can say it is variable speed. Okay, these are nothing but only some terms which are said to as a speed, because these are all the form of speed, and we are already defining it for you, because you have to use these terms in solving of your questions. Okay, so it is also clear that what is non-uniform speed or variable speed with the help of this example. And now always remember that these last two terms, which is the average speed and instantaneous speed, are related. Okay, are related to what? These are related to the numerical formula. These are related to the numerical formula, and these are all only defined with the basis of numerical formula. So sometimes we also come across the average speed. What is average speed? I will give you an example, that whenever we have to find out average of something, suppose we have 5 numbers, 5, 6, 7, 8, 9, and we have to find out the average of these numbers. Then what we do, we sum up these numbers. Okay, we do what? 5 plus 6 plus 7 plus 8 plus 9, and we represent it by average, x bar. You had been studied this before in math class. And here all these numbers are added and these are divided by their numbers. That means 1, 2, 3, 4, 5. Okay, we are dividing it by 5, and the average from what? The average gives us the values of that speed which are common to all the terms. Okay, if we will add all the terms, 5, 6, 11. Okay, 11, 7, 18, 8, 26, 9, 26, 9, 35 by 5. We are seeing here that our speed comes out to be, or our value of average comes out to be 7. So we are seeing the common value, which is the maximum common value, means the approximate common value which are approximate to the all the values is 7. So that is given by the average value. And the same things happen in the average speed. Suppose there is a body which is traveling at a various speed at a various interval of time. Okay, at a 2 o'clock it is traveling with a different speed. Suppose it is traveling with a 5 meter per second. Okay, at another time it is traveling 5 meter per second, 6 meter per second, then 7 meter per second. Its speed is given here, and suppose we have to find its average speed. Then what we do, we will denote its average speed with the help of this V average. Okay, there is only a formula we had previously mentioned here, numerical. Okay, and what is its formula? Its formula is V average is equal to total distance upon my total time. There is a one formula which is, we can also represent it as a average speed. V average is equal to total distance upon total time. This is also a method, total distance upon total time. With the help of this formula we can find easily our average speed, as well as there is also one formula which is V average is equal to this formula, the value of speed upon my number of total terms. Okay, means 3 or any numbers we have. If there are n speed, then we are using n, we are dividing it by n. Then with the help of these two formulas we can easily define our average speed. Okay, what we are only doing, we are finding out the value of average. Clear? So it is very simple way. Here the examples is also said 5 meter per second, 6 meter per second, and all the speed conclude to one time, which one speed which is the 7 meter per second. So this was the average speed. Now let's talk about instantaneous speed. Now the next term which is related to our speed is the instantaneous speed, and we can clearly also define at the same manner we had defined previous three topics, previous three terms. We are defining here the instantaneous speed. We had already defined about speed, that what is speed, and instantaneous speed means the speed at a particular instant. Okay, the value of speed at a particular instant is defined as instantaneous speed. Suppose we have to define the speed of a body at what time? Suppose we have to define at a 2 o'clock. If we have to define the speed of a body at a particular time, just after 5 seconds, or just before, just after 5 seconds, or just before, we can say 3 seconds. Okay, if we have to define the speed of a particular body at a particular instant, then we have to use our instantaneous speed. Okay, so it is what? It is the, we can write its definition. A is the speed of a body, speed of a body. It is the speed of a body at a particular instant, at a particular instant. Okay, so it is very clear here that what is instantaneous speed. And now if we will give here an example, as well as first of all we will give here formula. So what is the formula of instantaneous speed? So the instantaneous speed is written as the same symbol, which is the symbol of V. Okay, V, because it is a scalar quantity, so we can write it here as a instantaneous speed V barabar instantaneous speed V equal to what does it gives us? It gives us the speed. So we can easily write it here that it is giving us speed. Okay, it is giving us speed, but the speed is such that it tells us about the speed at that time at which our time tends to 0. Okay, this speed is at that time at which our time is tending to 0. That speed is known as instantaneous speed. That means the change in time is 0. Here delta t means the difference between two times. Delta means what? Delta means difference. We can see here as a difference. Delta means difference, and delta t means difference between two times. T2 minus T1, higher time minus lower time. As well as any quantity have delta sign, it says us about the change, or we can say here change. Difference means the same thing as change. We can say that instantaneous speed is what? It is the limit of delta t tends to 0 upon delta t. Okay, this is the only simple formula. Instantaneous speed comma V is equal to limit delta t tends to 0 delta r upon delta t, because we already know that speed is equal to distance upon time. Okay, and here the total distances is here saying us, okay, what is the total distance? Delta r is representing. It is also same as what we are defining here as speed upon time, delta r upon delta t. Okay, no, distance upon time, it is also same, but here the values are set at that moment when our time tends to 0, means the change in time is 0. Means if we are talking about 5 o'clock, then it is exact 5 o'clock, not before 5 o'clock, not after 5 o'clock. It is the exact value of our speed. So instantaneous speed gives exact value of our speed at a particular time. That's why our this factor, our denominator factor tends to 0